So today's small topic about the power I'll discuss. Power is a rate of work done. Power is equal to W by T is the general formula of power. So here power has two definitions. One is average power and instantaneous power. Average power is defined as the total work done in total time. Means in a given time, the work done is called average power. Instantaneous power is like the power of object at an instant. So those two are not same. And in the calculation of instantaneous power and average power, so instantaneous power means dW by dt will follow, and average power means the total work done, W by T only. So this T tends to small 0, T tends to 0, very small interval, then power equal to dW by dt. Initially, the power of a motor or engine, any object, inversely proportional to T for work done, constant. Power is proportional to work done, where T is constant. In the given time, the which one have the capacity of doing more work has more power, and in the given work, who are doing in less time, they have more power. So work is equal to, for example, climbing a tree. Will take less time, he has more power. He or she has more power. If a motor filling the water or iron box used to iron the shirts, so which is taking less time to heat, that have more power. Means it is doing more work done. Or motor filling the tank, which takes less time, that one have more power, more horsepower. The power measured in horsepower for motors. So coming into here, in average power, the work done can be written as F into S, depends on the given values and situation. Sometimes the work done equal to half mv square or change in kinetic energy or dE by dt. dE also you can take. dE by dt means that is instantaneous power. Two cases, power constant or force constant. That time only P equal to F dot V, depends on the given data. And work done equal to mgh by T. So P relation, now relation between P average and P instantaneous improving. First I will take P average is equal to work done by time, that equal to MAS by T. So here S is equal to half AT square, T to get cancel AT. So now I want to convert into instantaneous power. First I must know about the instantaneous power. So instantaneous power, when T tends to 0, the interval of time is very small, T tends to 0, then average power becomes instantaneous power. Therefore dW by dt, it will be expression for instantaneous power, that equal to F into ds by dt. So MAS by T na average, therefore F into ds by dt, that equal to F dot V. Mean this average power MAS by T I want to write in F dot V. So in this cases, this is F, MA into F only, keep like that. So here S equal to half AT square, distance traveled in terms of V I want to change. That's why AT equal to V I can write. The AT is equal to V. Therefore FV by T or MV square by 2. This is also one formula. Kinetic energy by 2. From this also I can write F dot V by T. V by F dot V by 2. So here F dot V represents dot product of force and velocity. So power is a scalar. So therefore P average is equal to P instantaneous by 2. P instantaneous is equal to 2 into P average. So this is about power, average and instantaneous. So here power SI unit is watt. To honor the James Watt, we are taking the power is SI unit of power is watt. So 1 watt is equal to 1 joule by second, means 1 joule of work done in 1 second of time. Then the power of that object is 1 watt. Engine or motor is 1 watt will define. The rate of 1 joule of work done or capacity of 1 joule of work done in 1 second of time is called 1 watt of that object. So 1 joule equal to watt into second. P into T. W is equal to P into T. P equal to W by T. Therefore, the graph of PT, area under PT graph gives the work, because P into T is equal to work. Therefore, P means Y quantity and T means X quantity. Y into X is area. Dy into dx is area, or Y into dx is called area. So integral Y dx is equal to work done, we can write. Similarly, work done graph is given. Energy to time versus energy versus time graph is given. The slope of W and T graph will give power. P equal W by T. So that is. So there are another unit of power that equal to 1 kilowatt hour and hours power. So 1 kilowatt hour is the commercial unit of electrical energy, that is. So that here watt hour is equal to power. 1 kilowatt hour, watt hour converting into, watt hour is energy, watt into second, W into time we are doing here. So that is energy, watt hour, joules will come. So as per definition, watt into hour, watt into the second will go this side, second converting into hour, then it will be joules represents. So hour I am converting into 3600 seconds. Therefore watt into hour is equal to, will get 3600 joule into seconds, joule by seconds. So now kilowatt hour equal to 36 into 10 power 5 joules. Means one unit of electrical energy gives 36 into 10 power joules of mechanical energy. Keep this in mind. So this is not that much big unit, even though joules are very small units. Even though while you are consuming the energy, means using the electrical appliances, keep this in mind. Means you are using 1 unit of energy, electrical energy, to do 36 into 10 power 5 joules of mechanical energy. Means the electricity using to heat, or electricity doing the iron, or electricity using to work the ovens, industrial stoves and all. So there, the less units of amount only they will calculate efficiency and all. Even though we have to avoid using less energy, conservation of energy you have to follow to avoid the global warming. So now conversion of 1 kilowatt hour into 1 units. Calculation of 1 unit, it is commercial unit of electrical energy already I mentioned. So 1 unit is equal to NPHD by 1000 in calculations. It will be very important. Our calculation. This is one model of the problem in Olympiad exams, the normal group exams and all. They will ask on this model. Consumption of units, and after getting the units, 1 month this many units consumed by one of the electrical appliance, means for 1 unit this many rupees, then how we will calculate the money, and that how much money need to pay after 1 month as a current bill. So in that case, NPHD by 1000, 1 unit is equal to NPHD by 1000. N means number of appliances, H means hours utilized or worked by that appliance, power is P is power of that appliance. So in some of the appliances they will rate voltage and current, then power is equal to VI. In some of the appliances they will write current, amperes and rating, radius, means resistance. In some of the appliances they will write voltage and resistance. So from these values, how much power of that appliance you can find out. So by this we can calculate the power of that appliances, how many hours, and they will ask this, especially separate month, Arjun Sen month they are asking. That means April, June, September, November. So 30 days only. Means specially they mention particular month. For that month, how many days are there? That many days you have to multiply. For February month, how much cost, how many units they consumed, means that 28. 28 or 29 depends on the year, you have to substitute. So particularly they will mention here D means days of month. Okay. That is maximum 30 only will apply. Right. This is about unit and this one. And power measured in hours powers also. 1 hours power is equal to 1 hours power small HP is equal to 746 watts. 1 kilowatt is equal to 1.34 hours powers. Because like this example problem they ask us here. So there is an elevator of mass 1800 kg moving with constant speed 2 meters second with help of motor. So there is a friction between the elevator to the elevator motion and motor is friction between the belt and motor, rotating motors, is equal to 4000, opposing the motion 4000 newtons. So therefore power consumed or power developed giving this velocity to this mass of elevator is how much. So power equal to here F dot V. Given that data, M is given, V is given, F is given, directly I will write power is equal to F dot V. So here F is equal to net force. So there is a friction force and mg. So now mg is equal to 18,000 and 4,000. Adding means you will get 22,000 into V is equal to 2 meter second volts. So 44,000 watts will come. But answer is asking in horse powers. This is the answer is given. Horse powers. So as we know, 1 kilowatt hour is equal to 1.34 horse powers. But here I got 44,000 watts. So that will be 44 into 1.34, you will get answer. So here in the same case, watt and joules application. So there is a waterfall. Some mass, some mkg of mass is falling from the height edge of the hill. So in this, the potential energy of this mass that equal to m into gh, potential energy of this mass. In this some percentage of potential energy, 50% or 30% to 40%, some percentage of potential energy is converting into electrical energy. So there are this electrical energy used to glow the bulbs of 50 watts or 100 watts or something like that will go. For example, potential energy is equal to 125,000 joules consider. So in this potential energy, in this 10% converting into electrical energy. That means 10% means 1 by 10, that equal 12,500. Joules of energy is there now. Electrical energy is there. Kilowatt hours. So this is joules only. So electrical energy this much joules is there. So this convert into kilowatt hours. So now I have 50 watts bulbs. So now they will ask how many bulbs can glow this by this amount of energy. 50 watts. Joule, watt equal joule by seconds. So means I want 50 joules of energy to glow 50 watts bulb for 1 second. So now 50 joules. So by 50. 25 bulbs I can make glow in 1 second of time, for 1 second of time. So there 60 watts is given by 60 or 40 watts is given by 40. 100 watts. So for example 100 watts are given. 12,500 by 100 watts. 12.5. That means here 12 only I can glow. 12 bulbs of 100 watts per 1 second I can glow. What about this 50 watts? 50 watts is not sufficient to 100 watts bulb. Therefore 12 bulbs will go, 50 watts will be wasted. So 50 watts is not, 50 joules of energy is not at all using. So I hope this is the one model on one energy converting into electrical energy. Here not only potential energy, electrical energy. So here another model, this is comes in not in energy, means all together energy, conservation of energy and power, like this model of questions will come. So there are many, so I am not going to all explain all, so you people will understand. So some model of another questions I'll give see. So there is another one conveyor belt is there, which is moving with velocity v initially. So there with some power, the motor is rotating, motor is running, not rotating, motor is running. So belt is moving with velocity v, then its power is equal, the motor power equal to F dot v. So here F means only the weight of this conveyor belt only. There is no work done, means to conveyor belt to move on the rollers, between the friction is then again the friction, the motor is doing work, a force is applying to move it to velocity v, therefore that is F dot v. So now on this conveyor belt some granules are dropped. dm by dt rate means in 1 second of time dm mass is falling onto this conveyor belt. So then to maintain the conveyor belt velocity is constant. To maintain the constant rate, at same rate the belt has to move. The motor need to apply more force, extra force it has to apply. That force is equal to F dash. The force applying now, this is not extra force. Force applying now is equal to F dash, the present force, to give the velocity constant for conveyor belt. So now F dash is equal to change in momentum. F equal to change in rate of change in momentum dm by dt. Therefore dm by dt into V plus V into dv by dt into m. dv by dt is constant here because velocity is constant, I said. So now the extra power required to this motor, which is rotating the conveyor belt with constant speed when dm by dt is falling, is equal to V square into dm by dt. Power required for that to drive the belt with the same velocity when granule of mass dm by dt is falling on with the rate dm by dt on conveyor belt. So there is a next model of calculation of power. There is a well. From the well, the water need to lift into tank of which is height above the height h. Otherwise, bore well, our sump in our house, there will be a sump of water. From the sump to the fourth floor building, h, height h. I want to lift the water and they are living in tank with velocity v. With velocity v, remember here. It has to come out from the pipe with velocity v. So in that case, the power of this motor which is doing this work is equal to potential energy. It is that power the motor is working to lift the water from from the ground to h height. At the same way, it is that is working to pump the water up with velocity v also. To pumping above from the ground, okay, now, and lifting the water means mass. So therefore, mgh and half mv square is the work done in t seconds. That is power of this motor in this case. So one example on this point I will tell you. So there is a well in 12 meters height. There is a well. So the water is coming out, means pumping out with velocity 20 meters second inverse with the help of pipe, motor pipe, and 1000 kg of mass I want to get in 1 minute. So that motor is pumping from the 12 meters height with velocity 20 meters second inverse, this much mass in 60 seconds. Then how much power that one should have? That must have how much power? Here G equal to 10 for easy calculations I am taking. So now as we discussed, power is equal to, in this case, mgh plus half mv square by t. If substitute means you will get answer 5333.33 joules. So this is. So in another case, another model. So in the same example, above example, for example, this water has to come with v velocity. Now it is coming with v velocity. This velocity need to increase n times, or the water has to fill in n times faster, or n times more amount I want to get, n times more amount. So in that case, if I want to n times more water or more with more force, the force must be increased to n square, because when water is ejecting from a pipe, then force is equal to rho a v square dp by dt. From that formula we will get m is equal to, therefore m is equal to v rho, that equal to area of the cross section into l by t, dl by dt into rho. So this rho a v, mv is equal to, we will get, this is dm by dt, the water is coming out, that equal to rho a v dm by dt. So now dm by dt into v is called, v into dm by dt is called force, that equal rho a v square. So now force is v square, v is equal to n times v, therefore force must be n square times of force. So power is must be n cube powers of initial power. So this is to increase the n times of water velocity of the water to n times in wetting the field. So their power is to increase n cube times. So now next model, the velocity is accelerated from rest, means sorry, the vehicle accelerated from rest, and this engine, this vehicle's engine is releasing constant power. Releasing means supplies constant power. So where power is constant and accelerating from rest, so these are the equations, kinematic equation of that vehicle will get. So from these equations, the velocity of this vehicle is proportional to t power 1 by 2 at constant power. And the displacement is equal to t power 3 by 2. This we are going to prove now. So see, power is equal to power of that engine of a vehicle is equal to dw by dt. So here w is equal to work done MAS. So that will be anyhow dw by dt means instantaneous power F dot V. So now P equal to m into dv by dt into V. So F equal to ma equal to dv by dt into V. So now T is have limits 0 to time t seconds, and V have limits 0 to V. At t seconds velocity is V. At 0 seconds velocity is equal to initial rest from starting from rest. Therefore you are applying, will get V equal to 2 pt by m whole power 1 by 2. So here this is m. Therefore velocity proportional to t power 1 by 2 and constant, it is independent on p and m root over 2p by m. That is constant terms for a given mass. So now from the velocity I can write ds by dt. So this is velocity. ds by dt is called velocity. So velocity is equal to, I got 2p by m into root t, that equal to t power 1 by 2 proportional to t, v proportional to t power 1 by 2 from that equation. Then ds is equal to integrating, I will get 8p by 9m into t power 3 by 2. 8p by 9m is constant. Therefore s proportional to t power 3 by 2. Where constant power is acting of a vehicle which is moving from the rest, then its final velocity proportional to t power 1 by 2. The displacement traveled or distance traveled is proportional to t power 3 by 2. So this is the power of a engine works, right, with respect to time. So now another example you take. So there is a particle of mass m moving in a circle of radius r with a centripetal force varying with respect to time as given. Fr equal to k square r into t square. This is the force of this particle in the circular path, centripetal force. So we know the work done by centripetal force in the circular motion is 0 because the centripetal force and velocity are perpendicular. Motion is perpendicular. Therefore, work done between, in the next video I will make it types of work done. Work done will be, work done is perpendicular, then work done is 0. Work done is 0 means kinetic energy is constant, then only work done is 0. And the power of this case, in this case power is how much? Power of this particle, or to move a particle in circular motion as like a given force, centripetal force like this, then how much power is needed to make it, to achieve this. Therefore here two methods are there. Easy method is equal to power equal to dE by dt, and here E is equal to half mv square. Half mv square means from this you will get mv square by r is equal to given k square r into t square. From that I will get answer is k square r square into t. If not like that, so if I want to go power equal to F dot V, this is also power formula. So if I want to use this one, so here F is equal to net force, not only centripetal force. Centripetal force means Fr into V is equal to F dot V, and those two are perpendicular, dot product is 0. Work done, right? The dot product of two vectors is 0. So now F is equal to net force, that equal to Fr into Ft. Here Ft is equal to MAT, force, tangential force, MAT. AT is equal to the rate of change in speed, dV bar by dt. Velocity already we can find out by using this mv square by r equal to. Then that velocity you are derivating. Okay, you will get kr by root m. dV by means velocity is equal to dV by dt. V you find out first of all. V equal to here see krt by root m, because mv square is equal to k square r square t square. Mv square is equal to k square r square t square. Then v square is equal, v is equal to krt root over k square r square t square means krt by root m. This is. Now here derivating dV by dt will get kr by root m. Therefore MAT derivation of means rate of change in speed is called tangential acceleration, m into dV by dt. So these values you substitute means Ft is equal to m into kr by m. This I can write the root m into kr. So however you can change, if you want to change, we change, otherwise directly can substitute. Finally we will get to the same answer only. So now power is equal to Fr, centripetal force dot V plus Ft into V. This is equal to 0 because those two are perpendicular, you know very well. So Ft into V, Ft I got m into kr by root m into V also I got, that equal to krt by root m. Cancel remaining things, you will get k square r square into t. So this is about power and its some applications. the efficiency of the power will write. So efficiency. So actually in viscosity will write efficiency of a Carnot engine eta is equal to 1 minus Q2 by Q1. Okay, Q1 minus Q2 by Q1, that is equal to 1 minus Q2 by Q1. So here Q1 is equal to, source heat energy, Q2 is equal to sink heat energy, or 1 minus T2 by T1 also you can write. T2 is the temperature of sink, T1 is the temperature of source. So here also P output by P input. P out by P in is efficiency. So on this also some models are there. So you can, because I didn't taken that models. So here all examples I have given. And commercial unit I have given and how to calculate everything. So I think everything is over. So power average, instantaneous power, the relation between instantaneous power and power work done, power time, all these things, relations, and then some cases of power. Thank you. Next model of the problem. So next model. The speed v reached by a car of mass m traveling a distance x. The car of mass m moving with the speed v covered distance x and its mass is m. And power is given constant power. Power is constant power. So then v is given by the speed of the car is equal to given by. Therefore we know power is equal to constant power. This is therefore f dot v I can write. That is m into v dv by dx in the a place into v. So therefore p into dx is equal to mv square into dv. So now integration from the x integration 0 to x and v integration 0 to v. So therefore p into x is equal to mv cube by 3. So now 3px by m whole power 1 by 3 is equal to v. Actually if you see at constant power moving with acceleration a, then v proportional to means here the s proportional to power 3 by 2 we got. Power is constant as well as it is moving with the constant acceleration. Then v proportional to t power 1 by 2 and s proportional to t power 3 by 2 constant power. Now here the v proportional to x power 1 by 3. So now from this also you can bring. Okay, right. So next question. So power is given. So power is given by P is equal to, means power is not constant here, it is varying with the time. So the relation of power with varying with power is given 3t square by 2 watts. So this is given power. And mass of the particle is 2 kg. So now here t is t in seconds. At t is equal to 0, the velocity of the particle, initial velocity is also 0. So now at t is equal to 2, the velocity is equal to question mark. Means here see power is varying with t. We know actually power is equal to dE by dt, right? dP is equal to power equal to dE by dt, energy by time. Already slope time I have given there, slope and area. So now E is equal to here dE, means change in kinetic energy, is equal to power into dt. So here dE I want to find out, that is half mv square is the dE. So that equal to P into dt, means P is equal to here 3t square by 2 into dt from 0 to 2. So that is equal to 3 by 2 is taken common, t cube by 3, limits are 0 to 2. So these 3 get cancelled. So answer will come 4. Therefore half mv square equal to 4. And m2 to get cancelled. Therefore v is equal to 2 meters second mass. So this is answer. So like this you can find out. Problem like that. Another last model of the power. Another model, see. So we have already the force is equal to, we have taken k square r t square. Force is varying with respect to time. Here k is constant and r is the radius. So this is centripetal force Fr is given, radial force, k square r into t square. So from this we find out the power. So power is equal to, finally we will get F net into V, that equal to Ft tangential force into, we will get V bar. So to find out the Ft, I will do MAT. M into AT. AT means D into the velocity, magnitude of velocity by time. Tangential acceleration means magnitude of velocity by time. And this velocity we will find out from this, that equal to k square r square means krt by m will come. The velocity is equal to, in above, in this, so in this only I have given krt by root m will come. So now we are doing that AT is equal to kr by root m will come. So now this and all is substituted. Fr into dot v is 0 and only ft dot v only is giving the power. So that will calculate it. K square r square t by m, I think so. That is the answer. So above somewhere I have explained. I think here. Yeah, here you can see k square r square into t is the power. So coming into this model, in this row they are given AC, centripetal acceleration is equal to k square r into t square. So see here centripetal force is given, here centripetal acceleration is given. This is only different. And asking to find out the power. So here power I got, in this case power is equal to I got kRt, right? Ft into V equal to kRt by m. So m is there here. So if you substitute means m into dV by dt means at, that is MAT. Kr by root m means root m. So root m get cancelled means kRt will come. That means power equal to k square r square t will come. K square r square into t. This is answer, right? So here you can see power k square r square into t, correct. So now here yes, AC is given. So the same power is equal to again Ft dot V only possible when it is in moving in circular path. Because in a circular path, the work done by centripetal force is always 0. So power is also by that force is 0. So then power is only due to F dot V. These two are in a parallel vector. Dot product exists for parallel vectors in that model. And power is the dot product of force and velocity. So now from this we will find out the AC now. From AC V square. V square is equal to k square r square into t square. So then V is equal to, that implies V is equal to k r into t. Here m is not there. So now I want to Ft. Ft is equal to MAT. That equal to m into dV by dt. Speed, that equal to m into kr, mkr. So now substitute here. Therefore P is equal to, here P bar not, it is right. P is a scalar. So P is equal to FAT means mkr into V is equal to krt. So that equal to m k square r square into t. So here MAC is given, where MAC is equal to k r square t is given, means their answer is equal, power equal to k square r square t. So where only AC is given, the power equal to m into k square r square into t. So this is the maximum model on the power, like this one will come.